Hello students, welcome to Narayana online classes. Today we are discussing 10th standard mathematics assignment number 36 in the topic trigonometry. Now the first question, 1 minus cos square theta, the value of 1 minus cos square theta. So we know that identity, trigonometric identity, sin square theta plus cos square theta value is 1. Now send plus cos square theta to right hand side. Therefore sin square theta is equals to 1 minus cos square theta. So what you observe here, so 1 minus cos square theta we can write it as sin square theta. So now the option is B. Next question, tan square theta is equals to, so here he is giving some options, 1 plus cos square theta, secant square theta minus 1, and 1 minus cosecant square theta, and 1 plus cot square theta. Then which is suitable for this? Tan square theta, right? We have our identity, secant square theta minus tan square theta is equals to 1. We need to calculate tan square theta. So tan square theta sent to right hand side and 1 sent to left hand side. So now secant square theta minus 1 is equals to, we are sending tan square theta to right hand side, right? So plus minus tan square theta, right? Plus tan square theta, and we are sending 1 to left hand side, so plus 1 turn into minus 1. So secant square theta minus 1 we call it as tan square theta. Now what is tan square theta, which is equals to secant square theta minus 1, secant square theta minus 1. Now the option B. Next problem, show that tan square theta plus tan to the power of 4 theta is equals to secant to the power of 4 theta minus secant square theta. He is given that we need to show, take LHS to prove RHS, or should take RHS to prove LHS. Now I am taking LHS, so left hand side part I am taking, left hand side of the part of this equation. Now from the left hand side part, that is tan square theta plus tan to the power of 4 theta. Now in these two terms, here tan square theta is there and tan to the power of 4 theta is there. So tan to the power of 4 theta we can write it as tan square theta into tan square theta. So take tan square theta as common. In these two terms, take tan square theta is common. So tan square theta and 1 plus, here we are taking tan square theta is common, remaining is tan square theta. Now here if you observe that we have an identity, secant square theta minus tan square theta value is 1. Therefore secant square theta is equals to, we call it as, we are sending minus tan square theta to other hand side, that is 1 plus tan square theta. So in place of 1 plus tan square theta we call it as, we are keeping as secant square theta, and tan square theta we call it as, from this we can write tan square theta is secant square theta minus 1. Tan square theta we write it as in terms of secant square theta minus 1. By using identity, secant square theta minus tan square theta is equals to 1, and 1 plus tan square theta we call it as secant square theta. Now secant square theta into secant square theta, secant to the power of 4 theta minus 1 into secant square theta is secant square theta. Now we are taking LHS, proving RHS, right? Therefore hence prove. Now the next problem. He is given if tan x is equals to 5 by 12, here the angle is x, we don't know that angle, but tan x is equals to 5 by 12, then find secant x. We need to find it as secant x by using identity secant square a minus tan square a is equals to 1, while I am saying that the secant square x minus tan square x is equals to 1. So secant square x minus tan square x is equals to 1. Substitute these values. So secant square x is equals to 1 plus tan square x. Therefore secant square x is equals to 1 plus tan square x. Tan square x we call it as 5 by 12 whole square, which is equals to 1 plus 5 square value is 25 and 12 square value is 144. Now so 144 into 144 plus 25 is 169 by 144. So secant square x is equals to 169 by 144. We need to calculate a secant x, which is equals to root over 169 by 144. So root over 169 by 144 is 13 by 12, right? If tan x is equals to 5 by 12, then secant x is equals to 13 by 12. 13 by 12. Now the next question. Prove that root over 1 minus cos theta by 1 plus cos theta is equals to cosecant theta minus cot theta. Now I'm taking a LHS to prove RHS. So now taking LHS left hand side, which is equals to root over 1 minus cos theta by 1 plus cos theta. I'm multiplying both the numerator and denominator by 1 minus cos theta. So 1 minus cos theta by 1 plus cos theta into 1 minus cos theta by 1 minus cos theta. Here both the numerator and denominator, by multiplying the same quantity, then the ratio doesn't changes, right? So 1 minus cos theta into 1 minus cos theta, 1 minus cos theta whole square. Here if you observe that 1 plus cos theta into 1 minus cos theta, a plus b into a minus b, a plus b into a minus b is a square minus p square. So 1 square minus cos square theta. Therefore root over 1 minus cos theta whole square by 1 minus cos square theta. Now here if you observe that 1 plus cos theta whole square by, here 1 minus cos square theta, by using identity sin square theta plus cos square theta is equals to 1. So sin square theta plus cos square theta is equals to 1, then 1 minus cos square theta we call it as sin square theta. 1 minus cos square theta we are write it as sin square theta. How? See here children. Sin square theta plus cos square theta value is 1. Therefore sin square theta is equals to 1 minus cos square theta. So in place of 1 minus cos square theta, I'm substituting sin square theta. So here if you observe that squares root get cancelled, remaining is 1 plus cos theta by sin theta, which is equals to 1 by sin theta plus cos theta by sin theta. So 1 by sin theta is what? Cosecant theta. So 1 by sin theta is cosecant theta plus cos theta by sin theta is cot theta. So let us, we are proving, we are taking root over 1 minus cos theta by 1 plus cos theta. Let us, we are proving, now we are proving cosecant theta plus cosecant theta. See here children, if you observe that here is minus cot theta. Thank you students.